Piece of cake. Speaking of cake, greetings, the Astro 30 here yet again with a brand new video for you. And today, magically, my preamplifier PCB has finally arrived. Every time I get a new PCB box, it's like Christmas, because yeah, it's like open it up to see what you get. I mean, I know what the quality is like. I mean, it is pretty good every time I have a PCB made, but of course I only ever see it in the CAD program. I never actually see it after it's manufactured until I get it. So it's always exciting. So we'll just open the box. These boards are the indicator boards with the LEDs to show you which input selected, and this is the preamp board. Oh, it actually looks quite sexy. It'd be a shame to put components on it. So anyway, let me get one of these out of the packet and we'll have a proper look at it. It's actually a thing of beauty. It's like a work of art. Oh, it just looks so beautiful. And I've tried to, lay it out as logically as possible. So the audio chain is actually going this way through the board and then comes out this side. It's just really for, keeping the layout clean, and also to try and limit the possibility of noise being introduced into the circuit because of poor layout. Like for instance, the ground plane is in the middle on the top. So its DC ground is over here and its audio ground is actually over here. So the audio ground path comes in this way, goes through the circuit back to the DC ground. Well, at least that's the theory. And that's the front, and this is the rear of the board. I mean, there's not much to see. It's just a bunch of routing, but the routing is pretty clean and pretty tight, I think. And I'm really quite pleased at how this turned out. And I just want to talk a bit more about the front here. If we notice down over here, you've got two copper tracks which don't seem to be doing anything. Well, they're going to two little wires either side, and that's to jump over the tracks underneath. Because when I was routing the bass treble circuitry, I just could not get, I believe this is the output, could not get the output back out of the circuit because the input comes in this way. So it sort of made it, a little bit difficult, and the only way I could solve it was to use wires and jump from the other side and come to the top, put a link wire for all intents and purposes across to another wire, and then back down to the other side. So that's the purpose of that. It looks fairly straight as far as I can see. It's not bowed or anything, but the finish is not that great at the front on this batch of PCBs. I'm not sure why, but there's a nasty nick in here too. Don't know what happened there. I might use another PCB, but yeah. And that's basically all I can talk about this PCB. Oh, over here we've got an LM7824 24 volt regulator, and it's being designed to lay flat on the board, and you put a heatsink under it, because this regulator not only powers the amplifier circuitry, it also powers the little 12 volt regulator down here, which powers the function switching, which will go off to another board for the input selection. It'll be probably running a bunch of relays. So there's going to be at least a good, I want to say 60 odd MA coming from this regulator because of the relays and the LED that will be on, which I'll discuss in a minute. And so I don't expect the preamplifier circuit to draw any more than 100, 150 MA on its own, but that IC is going to get considerably warm, so heat sinking would be advisable. Plus, because it's going into a low profile case, that's the reason why it's laying down flat. Anyhow, let's look at the indicator board. And here it is here. It's a tiny, tiny little board, and it's double-sided, but I made it, this is the rear, I made it so that the socket to connect between the two PCBs for the functionality was on the back side of the board. So this side, which is the front where the LEDs mount through and the resistor, or even the resistor could go on the back as well, I suppose, is that this will go up against the front panel and be secured by these two screws. So yeah, if there's like only 3 or 4 mil gap here, there's not going to be enough room for the connector, obviously, even an angled one. But I thought it would be easier just to pass the wires through the hole on this board, hard solder it to this board where the socket usually is, so it would come in from this side and solder to that side, and then put a plug on the other end of the cable. So it's disconnectable at the preamp end, but it doesn't really need to be disconnectable at this end. So that's my input indicator board, and that'll be assembled last because the holes in the front panel will have to be drilled and lined up properly. And also, once I've got the spacing behind the front panel from this board, I want to actually pass the LEDs through the hole into the board so that the LEDs are out flush with the front panel, and then solder it once it's actually screwed in from the back side. So the LEDs are the correct distance away from the board and up against the front panel where they need to be, rather than just guessing. I will show that a little later in the video. So I'm probably not going to get around to doing any assembly on this today. It will be assembled in this video, but it's getting very late in the day and I don't really feel like doing anything technical, so it'll be a tomorrow project when I'm fresh. But what I will do is I'll just double check the components that I got for this fit. So this is a switch, a 4-position 2-pole switch, which I got from Alltronics. It has common on one side in one direction and common on the opposite diagonal side for the other switch, which makes it kind of complicated and it kind of confused me when I was routing it. But what I want to do is I want to see if that fits in the footprint that I actually had to make specially for it, because KeyCode didn't come with one. Yes, it does, and it just lines up with the edge of the board flush like it needs to. Beauty. Now, hang on a minute. And I received another box in the post. This is from Mouser Electronics and it's to do with this preamp, so I'll just do what it says, which is to pull here open, which didn't seem to achieve much. Lovely. I have 3 potentiometers. You may be asking yourself, well, can't I just go to J-Car and buy the potentiometers? Well, not these type. These are a special function potentiometer. So let me just open the bag here and get one out. I don't need all of them out, just one. Pins are really bent on this one. I'll have to straighten that carefully, but anyway, these have what is known as a center detent or center click. So there, it's center clicked, so that's where the center of the pot is. And I'm using that for the bass, treble and balance pots. So that's why I've ordered them from Mouser. And I've also got some 560 ohm 2 watt resistors to replace that 560 ohm 1 watt resistor in the power supply. So yeah, things are coming together. Alright, so I think we should get going on construction of this preamp. Well, that was handy for that to show up now. Now this is a switch, a pot that I bought from J-Car, it's the 50k logarithmic one. As we can see, the shaft is a lot shorter, and so is the mounting position. It's probably about a millimetre or so different. Anyway, I want to make sure that fits in the board properly and lines up with the thing. Don't tell me those holes are too small. Oh no, I can just get it in there. Good eye. I'm worried there for a sec. Okay, so that doesn't look too bad. I'll put that switch back in for reference. Yeah, it looks like it's lining up flat with the front. So let me grab those other pots that I was talking about. Right, and I have gone ahead and straightened the pins on these, so yeah. I haven't got the hardware mounted on it. I just want to make sure they are exactly the same as the J-Car one. Yep, indeed they are. They line up almost perfectly with the front. It's probably, I want to say, probably about 1/2 mil gap there. So what I might have to come up with is put a washer behind it before screwing it to the front panel, so it's not actually putting stress on the board. This one I probably won't have to because it looks like it lines up with the front perfectly. But there is probably about 0.5 mil difference. But the shaft's the same length on these two pots, so that's good. And this has a nice positive center click. Isn't that special? And what I'm going to do is, with the assembly of this, I'm going to put all the components on the board, capacitors, resistors, even the pots I suppose, but not the transistors at this stage. I will install the 78L12, but the reason for that is I want to install this regulator, and with nothing else connected I want to make sure that the regulator is actually functioning, putting the correct voltage out, because there's nothing worse than it putting the incorrect voltage out and destroying the transistors. So I'll just make sure that there is, 24 volts here at the DC out jack over here, which is the plus 24 V-reg, which comes off of the regulator's output. And the 78L12 also comes off of that same regulator output, as I said. And I want to make sure that there's like 12 volts being switched on, well, this board, this connector here on the board, because there should be a positive voltage here and a ground all the time, and between ground and each of these individual connections should be switched with the rotary switch. So that will be what I'll do to test it first. Then I'll install the transistors, and I'll probably just add fly wires for the input and output connections just to quickly hook it up to a scope to test it. And then I'll solder the correct sockets in, because it means making up those little JST connectors, and they're a pain in the ass. And well, they are without the right crimping tool, of course. And yeah, test it, make sure it works. I want to see what its full output voltage swing is and what its maximum input sensitivity is, vice versa. So we've got a good baseline to work with, and then it will come down to drilling the holes out in the front panel to support the board, but I'm going to have to come up with some washers from somewhere. Alright, it's the next day, and I've actually gone ahead and soldered all the components on, apart from the regulators, the pots, the switch, the sockets and the transistors. Now, I actually did all of this yesterday afternoon with the computer on, just listening to some video in the background. And incidentally, I've actually been using the 2 power amplifiers in that amplifier project for the last 3 or 4 weeks now, with a little pot on the input there, so I'm not overdriving it. And it's worked flawlessly. Absolutely fine for the last 2 weeks, no weird noises or anything. There's a little bit of a mains buzz in one of the channels, but that's most likely due to my grounding. Anyhow, I want to talk about something else first. I didn't take much footage of constructing this because, well, there's not much point to that. These little pots have a little location dowel on them which stick out about 1 millimeter. Now this will prevent the pot from mounting flush against the inside of the panel, but I've got a 1/2 mil gap there anyway, which needs to be filled up with a washer. But if this is not removed, and if the washer's slightly larger, it'll cause the pot to twist as it's being done up. So this will need to be cut off. So I'm just going to take a pair of side cutters and just do that to all the pots, so it's relatively flat, because that pin's not needed. And this one's the volume control, so that can go where it goes, which is there. Okay, looks like all the pots are now soldered in, which is good. So I also forgot a 10k resistor over here, so I've fixed that now as well. So you may be asking yourself, why are these capacitors bent over at an angle? Well, I did that so I was making sure that it would clear the inside of the case lid, just in case they make contact. They shouldn't. I'm now going to put the 7812 in, 78L12 rather, little TO92 regulator, if I can actually get the thing to do as I want it to do, which is go in the holes. But it's proving awfully challenging for some strange reason this morning. Right, there we go. It should be far enough down so I can solder him in, and then I'll trim the leads off. I want to do the 7824, so I need to know how much I need to bend those leads first. Right, I need to bend it right up at where these notches are, which is right on there. So that will get bent over like so, at right angles. And what I'm going to do is I need to find a heat sink, and I'm going to use one of these isolators and bushings, so I'm not, there's 4 in there. So it's not in contact with directly with the heatsink and the circuit board, so it's actually, the device is isolated from, well, everything really. Plus it gives a bit of heat transfer. One of these. Jaycar sell the slightly larger version, it's 19mm across, I believe it is. That'll still fit on the board just nicely, so you can use one of those if you have to. I just have one of these readily available, so that's what I'm going to use. Bolt's probably a little bit longer than necessary, but okay. Let's make sure the heatsink is straight, which it appears to be, so then I can use a pair of pliers now to hold the nut whilst I do the screw up properly. And it doesn't have to be overly tight, just as long as it's, you know, snug. So then I can then turn this upside down once I work out my English, and I can solder the pins on the underside, but the weight of the board keeps causing this to drop. So I'll tighten that. Right, regulator is in. So then all I have to do is just put 2 little fly wires where the DC input is, just to get power into it. And then we can do the first test, which is voltage measurement. I might touch that center lead up again because its soldering doesn't look all that great. So I'll just fix that now. Make sure the rest of them are done properly too, now that I've cut the leads. There we go. Perfect. Alright, I've got everything set up on the bench. I've got my AEL 480, ETI 480 power supply clone, my 25025 volt toroidal transformer because it's convenient at the moment, and that's hooked up to the positive and ground. Got the multimeter set up, so all I need to do now is just plug this cord in. Hopefully that goes off with a bang. That's fine. Okay. And I'm going to measure at the regulated voltage output. We should have 24 volts. We do, we have close to 23 actually, which is not bad. So yes, it's giving me 24 volts as it should. I'm going to change the ranging on that, speed I should say, to high, so it's actually a lot quicker at measuring. Yep, perfect. Right, now I need to measure what's coming out of my 2 sockets over here for the LED and switching. So that's V positive. That is L4. We should have nothing. So I'll put that on that one. We have 12 volts there. Nothing there, so I'll switch it down one. We should have 12 volts there. Yes. I'll switch it down another position. L3. We indeed have 12 volts. Nothing anywhere else. Nothing significant anyway. It's just going all over the place. Okay, and I'll switch it down one more. And we have 12 volts there. Okay, so between this connector, V positive, and ground, we should have constant 12 volts. We do. So if I go backwards now between ground, because this is a positive switched, we have negative 12 volts, or 12 volts, on position 4. On position C, which is position 3, we have 12 volts. Position B, or position 2, 12 volts. Nothing anywhere else. And on position A, which is fully counterclockwise, I'll do that again, we have minus 12 volts, or 12 volts. So I know that all my voltages are there. This switch is operating correctly and is giving me the correct outputs at the correct points compared to where it is rotated. So I can unplug that now, and what I need to do now is, well, install the headers for here, but I might do that a little bit later. Install some more fly wires here at the output and the input, and also put the transistors in, and then hook it up to an oscilloscope and see if we get an output. Right, I've got the oscillator set up, the volume controls up a little bit, all of these are in the center. I've got the oscilloscope connected to the left hand output and the oscillator to the left hand input. I haven't actually plugged it in and turned it on and tested it yet, so this is a first for both of us. So I'll plug it in, and well, currently I can't see any output. Oh, now I can. There we go. Okay, so this is going to be awfully awkward to do, so let me first change that to a better scale. There we go. Now currently we're pushing at 100 odd millivolt, so we've got a nice signal even though it's not triggering properly. Oh yeah. Right, so with the volume control all the way up, I'm getting 0.74 volt out, which is 740 millivolt, and it's nice and clean looking. So I'll just play with the bass pot. Oh yeah, because we're around about 500 hertz. The treble's not going to make much difference to it until I change the frequency. Yeah, the treble's having an effect on the signal. Beauty. Turn that back down. Well, I should be at 1 kilohertz anyway, I don't know why I'm not. There we go. So cool, we've got an output. So I know that that channel's working, so I'll just play with the balance pot. If I put it fully left, nothing happens to the signal. If I put it fully right, it disappears, as it should. Put it back in the center. Alright, so I know that that's working. What I want to know now is what is the maximum output and the maximum input sensitivity before clipping. So I'll put that on a lower scale and I'll ramp up the amplitude on the oscillator. Whoa, okay. Oh, there we go, we're clipping there. I want to say, that's about there, we're getting 5.5 volts peak to peak out before clipping. So I'll change the scale again. What I want to know is, it's actually still clipping there. Turn it right down. Make that 5.36 volt peak to peak. Now I want to know what our input sensitivity is. So before I check the second channel, I'll just disconnect all the wiring here and just join the two together. Alright, according to that we got 3.94 going in. Okay, so we had 5.36 volt coming out, and we divide that by what's going in, 3.94. That is a gain of roughly 1.3, which is okay. So now I want to check the right hand channel, so I'll plug it back in. Yes, we have an output. I've turned the oscillator back down, so we've got the same 0.75 odd volt out, so it's pushing the same. If I now play with the balance pot and turn all the way to the left, it shorts the right hand channel out as it should, and that's with it all the way up to the right hand. Okay, so the treble is doing something. Yep, and my hand's going to be in the way, but yes, I can see that the bass pot is doing something. That means that this is now ready to be finalised. That is, have all the connectors that I need to put on. So I need to remove all my fly wires now. And it'll be ready to start thinking about drilling the front panel of the case and installing it. I don't have any washers though to go on these three pots, because this is different depth compared to that one, but whatever. So anyway, it's good to see that it's working. It's got a clean signal. So yeah, now it's on to mechanical. Penis! Right, well, there's the preamplifier with all the connectors installed. I ended up putting a fly wire to the power connection on this side because, well, wouldn't you know it, the body of the footprint does not match up with the body of the JST header. It's actually a little bit wider, so it was coming into contact with this capacitor here, and it was bending at a slight angle, probably about 5 degrees or something. But that was totally unacceptable, so I've opted to put my DC in on a fly wire. It just plugs into the power supply down below. No great issue. Now I'm going to have the fun task of doing the audio cables and the LED indicator board, which is going to be a nightmare. But yeah, first what I will do is, though, I'll drill the holes out in the front panel to accept preamp at least, and the LED board, otherwise I'm not going to get anywhere. Okay, now comes the task of drilling the front panel. I've put a piece of tape up on top here so I know which direction it came off. That's the power switch, which is off screen here. This is for the preamp controls, and this is for the LED board over here. Now the distance between each LED's center is 8mm in the up and down position, and that equals a total of 24mm between the inner and outer LED, and it's also 6.5mm roughly between here and the mounting hole centers. I've made the selector switch 45mm away from the LEDs, so it matches with the distances here of 45 between the volume and the selector, and the volume and the balance. The rest are 35. So I'm going to drill this out, and then I'm going to start mounting components. Fun. Alright, I've got the holes drilled in the front panel now, and amazingly the centers of these two mounting holes lined up perfectly. However, the LEDs may have been drilled a little bit higgledy-piggledy here and there, so I've drilled out the holes to 3.2mm, so all the LEDs fit down flush against the front panel as we look at it from that direction. So now all I have to do with it mounted in the front panel is just at least solder one leg, and that's the alignment of the LEDs done. Everything's exciting here on the Astro 30's Electronics Lab. Now, with that soldered in, I can now remove the board and trim the excess leads off and then pass my wires through that need to be soldered from here to the board. Check it out, it's starting to look like a, well, amplifier I suppose. I've got the power switch mounted in now so that'll make it easier turning it on and off and it's not just hanging over the front like it was before. I've only done these up finger tight because I still don't have a washer behind these three controls. Again, these are finger tight as well, but now all I've got to do is make the interconnect between the LED board, the main board, put the front panel back onto the amplifier. I might change that 560 ohm 1 watt resistor to the 2 watt one whilst I'm at it. And then we can start doing some internal wiring. I've got to redo some grounds on the power amplifier, or power amplifiers, and also get the interconnect for the audio coming out to the power amps and the audio coming in from, well, the input circuitry that doesn't exist yet. So I'll get busy doing that. It's these cables are going to be the most time consuming part, but yeah, I'll come back when I've actually got something much more interesting to look at. Okay, after sodding about for the last hour and a bit, these two boards are now connected together. The power supply is connected to the preamp, although I've gone around the houses here for some stupid reason. I don't know why I've done that. And there's a chainsaw going in the background as well, which is wonderful. Get in there. Right, so that should be down there like that, that's fine. Now I need to test the operation of that switch, make sure that when this is all rotated fully counterclockwise, the first LED is on, and so on and so forth. So I'll plug it in, and I will somewhere. There we go. And I'll turn the switch on at the front. And the first LED is lit up. These are a bit bright, either that or that's too dull. I'll have to fiddle with that anyway. Next one. Ooh, yeah, that lights up. Is it the same brightness as the other? Yeah, it is. That one works, and that one works. Yay, cool. Right, now it'll be a thing of, I'm going to have to take this socket, desolder it, run the wires to the back here where it should be. I'm going to use crimp connectors this time. Drill a hole, couple of holes in the back to accept the socket, and I'm going to remove all this crap here and actually wire it up to the preamp so we can actually connect, well, the preamp to the power amp as it's supposed to be. And I also need to make up the audio lead, so it's another 4, 5, 6, 7 crimp connectors to do. Pardon. But if I jiggle the wires back there, there's no connection issue. I originally had the wires wired backwards, so it wouldn't have worked. So I had to unsolder it, change them round, and yeah, that really made my afternoon. The LED will stay on for a while. I mean, that's neither here nor there. There it goes out. Cool. Right, so I'll unplug that for safety. So yeah, next thing I have to do is fiddle with these grounds. I don't know if I'm going to drill these holes today or not. I probably should, it is just sitting there. Right now I'm going to have a bit of a break because I've been going at this for at least an hour and a bit now, and just doing 5 wires. So it's time I go do something else, like have a smoke, maybe a coffee, and then I'll sort out this output wiring, and then I'll sort out all the grounding and stuff here. Yeah, okay, cool. Okay, that was a little bit easier. The output of the preamp is now crimped into a connector into the inputs for the power amps. Now I've got the output of the left-hand channel at the moment connected to my big test speaker, so I'm not using my good speakers at the moment. It's plugged in, So I'll turn it on and see if it makes any rude noises in the speaker. Nothing. Ooh. That is very noisy. That's a problem. I ended up removing the 10 microfarad 25 volt capacitors that went across the 220 ohm degeneration resistor or emitter control resistor in the last transistor. It's still fairly hissy. And yeah, I'm not sure how I'm going to cure that, but sound wise it sounds alright when I can get it to play. Okay, let me hook it up to the other speakers that I'm normally using. Okay, apart from that loud hiss, it works fine, but I really don't know how I'm going to cure that hiss. I'm using BC549s, which should be, you know, more than adequate. But yeah, in the original design it used 150k resistors in the negative feedback part of the bass treble circuit, so I might have maybe too much negative feedback. That is a possibility. So yeah, I am kind of disappointed in that. I would have thought it would have worked better, and that hiss is going to annoy the piss out of me at night, I can tell you. Okay, so I wasn't really happy with how this turned out. So what I've got is I've got the left channel hooked up to a test speaker. This pot is actually going in series with the left input of the power amp and the left output of the preamp. And I've got it rotated a fair way up, and the hiss is not as pronounced. Now it is. Even down about there is fine. So how does this affect the gain of the amplifier? Well, there's too much gain here for a start, but it should actually attenuate how much is going in, and I can easily make that modification by just changing the 470 ohm resistor on the power amp to whatever this resistance plus that equals or thereabouts. So I'll hook it up to an audio source and we'll see if everything still functions the way it should. Well, yes, I've lost volume. But it's a lot better. I can press that. Press that a bit more. Treble's doing something. Oops, I just lost a wire. Hang on. Ah, you bastard. Okay. That functions a lot better and there's less hiss. It's not as loud and obnoxious as it was. So let me measure what the resistance of the pot is. Survey says 12k. So about 12k, maybe 10k. Yeah, I got 12k's anyway. Should attenuate that enough to make it not obnoxious. I've got two 10k resistors there jerry-rigged into the circuit, decided to the top side of the preamp board. I will install them properly later. It just means I've got to pull the power amp boards out to do it. I need to fix this output connector anyway and redo some grounding. So for now, I'll just leave it like that. The ground for the audio signal is still coming off of, well, the power supply really. So I'll plug it back in, turn it on, and make sure nothing's shorting. That is more acceptable. Much more acceptable. Penis! Right, it's back in its home. It's much easier to turn on and off it with the switch there, rather than hanging out the side. Now, yeah, I've got a bit of a buzz now. Why? Not exactly 100% sure. Could be picking it up from the audio lead. Oh my god, I lost it. I might go 15k in the end. Whoa, stream. Okay. Oh, now my computer is buggered up. Come on. Turn back on. There we go. Let's try that again, shall we? Because I'm touching the control. Yeah. Might have to do something about that so I'm not inducing noise into the speakers. Just give me 1 second. Alright, I stuck a couple of knobs on there. They're not the final knobs, but I've also grounded the front panel at the pot. That's because I was picking up noise off of touching the panel, so I'm going to have to look at why that's doing that. It could be because this is not actually earthed at the preamp properly, but it is what it is. Not doing it now. Yeah, it's an earthing issue. Alright, it's a couple of days later and I'm not happy with this idea here that I've got. That seems to be just masking an issue rather than actually solving the issue. So today's task is I'm going to pull the preamp back out. First I'm going to actually remove it from the case and I'm going to put a piece of cardboard up here and lay the preamp on top of it so I can work on it without having to keep removing it in and out of the case all the time. And I reckon what the problem is I'm using BC549s, which are actually a higher gain transistor than the BC547s, because it did not have that much noise when it was on breadboard. Well, when it was the original 2 transistor version. But so I reckon it would be the transistor that's in the active bass treble network here. So this has made this video a little bit longer than I wanted it to, but I want to cover all bases, so I'm probably going to change out the transistors. So what I'll do is I'll take the preamp out, find a bit of cardboard, prop it up, plug it in, and I'll see if the noise is still there with the preamp just sitting on top of everything. Alright, the preamplifier is out and just sitting on top of a piece of cardboard, which I'll just make sure it covers the whole entire lot. Okay, I've got the speaker hooked up to the right hand channel, the left hand channel is disconnected at the moment. Yep, still noisy as anything. Alright, so the first thing I'm going to do is I'm going to remove the input transistor here just to see, because that's the one that produces most of the gain for the amplifier or preamplifier. I'll remove him out of circuit. This is an emitter follower, so that should not really have that much of an effect on it. And then finally I'll remove this one. I'll clean the holes out as I go so I can just insert a BC547 in its place without having to solder it in. So I'll get going on doing that and I'll come back once I've got the transistor removed. Alright, the input transistor is removed, so let's see what happens. Still noisy, as I thought it would be. Okay, next transistor to come out is that one. Right, the emitter follower transistor is now out, and we'll see if that makes any difference. I don't think so, because that transistor doesn't produce any gain. I'm going to say that it's going to be the one in the active bass treble network. Let's turn it on. Well, the noise is reduced a little bit. So, yeah, I reckon it's this transistor. So let's pop him out, and I'll clear the holes as best as I can so I can insert a 547 and see if the noise actually reduces. Next course of action would be to mess with this 470k feedback resistor, for want of a better term. The original circuit was 150k. I changed it to 470 but never changed it back. So anyway, let's pop this transistor out and we'll see what happens when we insert a 47. Alright, the BC549 is out and a BC547 is just temporarily sitting in the holes. It's plugged through hole anyway, so it should still make contact. So if this doesn't fix the noise problem, I don't know what will. Yeah, well, there's still noise there. That's very interesting. I don't know what is with that. That's really annoying. I don't know what's going on with this pot. Anyway, right, so it doesn't matter what I do to this, it's still noisy. The bass pot's got an issue with it making crackling noises through the speaker, which is going to eventually damage the speakers. Seems to be okay with a limiting resistor in the output to reduce the noise, but this is just ridiculous. I mean, apart from redesigning the whole damn thing, which was a complete waste of money, this is, for all intents and purposes, useless. So I might just go with limiting resistors instead, because I can't do anything else. I'll see if I can actually just scrape a bit off the top of these pots and this switch and somehow get a tin bit of copper wire down underneath the board to ground these pots out. So, you know, I'll change out these transistors as well whilst I'm at it. I even removed the 470k, changed it to 150k, made no difference. Removed the 47 picofarad capacitor, made no difference. It does work okay without the 10 microfarad capacitors in circuit, so I'm going to leave them out. Anyway, I'm going to go have a cigarette, I think, and then I'll come back and do something with this, maybe, I don't know. Well, I couldn't solder directly to the pots because I think they're aluminium, not actually steel. But because I have to use some pot washers, which I've got on there now, behind the front panel, I've managed to actually solder to the nuts. So that'll make it a little bit easier. All I've got to do is just solder a bit of wire off here to ground it to the case. Because the reason is, this front panel is not actually properly grounded to, well, where the star ground is. There's like about 20 megaohms of resistance there. So yeah, that's an issue. So what I'm going to do now is, before I root around and modify the power amps, is I'm going to get this grounding wire in. I'm going to put this back in the front panel and do the nuts up tight and make sure that everything is functioning. I didn't put a short link over to the volume pot because, well, it's not needed really. Once this lot is grounded to the front panel, that will ground by default anyway. So that should actually bring our front panel to ground potential. So I'll put it back in, put the nuts back on and etc. and tighten it up and just make sure it still works. I've changed the transistors in the other side. I really need to test whether or not that section works, but I'm assuming it does. And the Lord said, I have no idea where I'm up to, because I've just spent the last hour messing about. I've now got the 10k resistors soldered in on each power amp module in place of the 470 ohms. It's turned on. Apart from a slight background hiss, I can't even really hear that much mains noise. If this wiring was tidied up, it'd be fine. So I found that the audio path ground, or audio ground path I should say, should go through the circuit like that, so going back out to the socket. That's the way I'm going to wire it. I don't think it makes any difference if I go there to ground, although I can't hear much noise. It's about the same. So I'll just switch channels. And it's the same. No noise, just a little bit of hiss. Tiny bit of mains buzz there. You can't hear it, but I can. Hardly any there, so I might actually ground my socket to here and remove the negative going lead out of this, which is going to be a pain because it's all cable tied in. So, alright, just give me a minute. I do tend to think the mains buzz is less pronounced when it is actually grounded to the star point, which is where it should be anyway. What I should do now is I'll switch back to the left-hand channel. Both channels are the same, no noise, and it is actually working. So I think I might ground it there. So what I might do is I might take the back panel off and drill the necessary holes to accept this socket into it, and actually wire this in properly and tidy this wiring up a little bit. Remove this ground from here, that ground from there, and yeah, so I can sort of make this more permanent rather than it just flopping around. So I'll get busy doing that and we'll come back when I'm finished. Well, there's the speaker socket installed there, and it's currently turned on, hooked up to the test speaker over in the right hand corner there. Yes, I can hear it's hissing, but it's not that bad. Thing is, what am I on the left channel? Still working, so oops, straight onto the floor. Okay, so what I might do, bang the tripod for the 1500th time and move this over on top of the test speaker and hook up the original speakers now, audio source, do a final sound test, and then we'll close this video out because it's going on way too long and I've now got to make sense of it all in editing. So I'll just set that up. Alright, play a track.
Doing crazy dreaming, you're the reason why I'm bothered, baby, losing my mind. Don't try to save me, I feel alive. My world is faster and faster, the tears and the laughter. I'm here for the ride.
Sounds alright.
I'm an emotional mess, yes, but you wouldn't want me less, yes, 'cause you know how wild it could get to love an emotional mess. In a trance, spinning out of control. Don't know what this dance is, but at least I'm not dancing alone. All kinds of crazy. You heard what I said.
Okay, that's enough of that. So, yes, it's a bit on the hissy side, but at least it hasn't got a really annoying mains hum behind it, which is what I was more concerned about. I can live with the hissiness. I mean, yes, that was, I'm not sure if you want to call it a cop-out by changing those two resistors, but yeah, I just think that the preamp's just got too much gain for what the gain setting of the power amp is, so modifying that by reducing the gain, it's only minus 20 decibels or something, I think it is, compensates and stops it sounding like you're at the seashore. Anyway, I'm reasonably happy with how that's turned out now. Wasn't a complete waste of time. It certainly can fill this room with music, that's the whole entire point. But anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below. And there are links in the description to my Patreon and Facebook page if you wish to subscribe to them. Anyway, this is the Astro 30 saying see ya. Have a great day.
Bye.